volume V3 and pressure P3. Okay, now what we have to do is, it is a compression. Now the gas is allowed to or the gas is compressed isothermally. What happens if we compress the gas? The piston is here. If we compress it, then what happens? It comes to this place here. The gas comes to here, and if we compress it, it again comes to the here. That is P4 V4. Again its volume changes to V4, and hence the volume changes from V3 to V4, and pressure changes from P3 to P4. Okay, work done. The process is isothermal, hence what it becomes, delta E equals to 0, and due to compression by using suitable negative signs, we can write it as here. What we have to take, consider W3 as work done, and Q3 heat absorbed. What happens here is, if delta E becomes equals to 0, then automatically, just see here what will be written here. It is not Q3, it is Q1, because the temperature is reduced. Temperature is at T1. Hence it is heat absorbed is taken as Q1. Okay, Q1 as heat absorbed. So Q1 becomes heat absorbed. Then what we have to do? If we apply the negative sign, then what it becomes, minus W1 minus W3 equals to minus Q1. Minus W3 equals to minus Q1, which is equals to, if minus cancels, then R T1 ln. We consider it from here, we are taking from here, then what it becomes, it implies V4 divided by V3. because we've taken here V2 by V1. This is the for ideal gas, RT1 ln V4 by V3. Once these gets cancelled, then what happens here? W3 equals to RT1 ln V4 by V3. Okay, and Q1 also equals to RT1 means minus W3 equals to this, minus Q1 equals to RT1 ln V4 by V3. It means like this. And what it becomes here is, again, we have to move this, we call it as equation 3. Okay, next step is fourth step, that is adiabatic reversible compression. In this step, what happens? I will show you. The gas is present at here. Now, if we again compress the gas adiabatically, it comes to the original state. It means it comes to its original state, that is V1. Okay. At point D, the gas, that volume V4 and pressure P4. Now the gas is compressed adiabatically. And so what happens? Hence the gas comes to its original state. Okay. Hence temperature increases, work done equals to what we have for work done. We got that W equals to minus delta E. Okay, so we are putting the minus signs. What happens here? It becomes again minus. Okay, W4 equals to minus of CV into the bracket. What implies T2 minus T1 minus of CV into T2 minus T1. T2 minus T1 it becomes. Okay, now total work done. What we have? Total work done W1 plus W2 plus minus W3 plus of minus W4. It is minus W4. It is minus W3. Okay. Now W1 we have to write it. It is RT2 ln of V2 by V1 plus of what we have W2. We have CV into the bracket T2 minus T1 plus of what we have W3. We have W3 as RT1 ln V4 by V3, and what we have, that is W4 is minus CV T2 minus T1. Okay, this and this gets cancelled, and we got the for total work done formula as RT2 ln V2 by V1 plus of RT1 ln V4 by V3. We can write it as RT2 ln V2 by V1 minus of RT1 then V3 by V4. If we change this, we can write this. If Q is the heat, total heat absorbed by the system, okay, if Q is the total heat absorbed by the system, then what we say it as